All right, we are live. Okay. This live streaming has started. In this video, we're going to solve, in this live video, I'm going to solve this coding interview question. Remove duplicates from sorted array. Given an integer array nums, sorted in non-decreasing order, we have to remove the duplicates in place such that each unique element appears only once. The relative order of the element should be kept the same. Let's take these examples here. In these examples, we have three elements. At the first two positions, we have to, we have here total two distinct elements. So we have to return the size of our sorted array without the duplicates at 2. And we have to update first two element with the unique element, and the rest we don't care whatever we have. And for this array of integers, we have total 5 distinct elements. So we have to return 5, and at the first 5 positions, we should have those unique elements. And in the rest, we don't care whatever we have here. We don't care. We just care the first 5 positions. This is the problem. We have to solve this problem in place. All right, there is no viewers actually. Let me check it on my YouTube on my mobile whether it is working or not. Let me check it. I think this live is working. I have to change the thumbnail. Unfortunately, I forgot to change the thumbnail, so it's remained the same. So let me change it. This thumbnail should be this. Okay, just save it. All right, so I think the thumbnail had changed. Now let me check it. I'm so sorry. All right, it changed. Now let's start with this problem. Now let's see how to solve this. Okay, so in this problem, we are given an array of integers. Let me write out all the elements. So first, the first element we have here is, let's draw here an array. 0, then 0, 1, 1, 1, 2, 2, 3, 3, and 4. This is our array of integers. We're given this array of integers. Here we have total 5 distinct elements. 0, 0, 1, 1. We have 5 distinct elements. Those are 0, 1, 2, 3, 4. So what we have to do at the first 5 positions, here we should have 0, here we should have 1, then 2, 3, 4. We have to modify this array something like this, and the rest part we don't care whatever we have. We just get this first 5 positions. We should update, and we have to return the size or the number of distinct elements we have. So we have to return 5, and we have to modify this array. We cannot use extra space. We have to do this in place. The constraint makes this problem a little bit tricky to understand, but don't worry. Let me show you how we can solve this problem. So what we'll use left and right. Left will point to the first, left and right pointer. Okay, left pointer will point to the first element, and right pointer will point to the first element. Now what I'm going to do, I'm going to check if left and right point to the same element, or if the value of left and right are the same. Then what I'm going to do, I'm going to just move right to the next. Now we see still left and right points to the same value. Let's move. Now we see left and right points to different value. So now what I'm going to do is that I'm going to just move left to the next. I'm going to move left to the next, and I'm going to update the value at left with the value of right. So let's update this value with 1. Hope you're understanding. Now let's move to the next. I will point here. We see their points to the same value. Let's move again. They're pointing to the same value. Let's move. Our rule points to 2. 2 and 1 are not the same. So I'm going to just move left to the next, and I'm going to update the value at left with 2. Let's move to the right. Here is it 2. 2 and here we have 2. So nothing to do. Now R is pointing here. We see the value are different. So I'm going to move left to the next, and I'm going to update the value 1 with the value of right 3. So we can assume that all edges on the left, we can assume all edges on the left of our left pointer. On the left of left pointer, including left, all the elements, we have the elements on the left, including left, distinct element. We have distinct element on the left from 0 to left, we can assume. So we're maintaining these properties somehow from 0 to left. Somehow we will store the distinct element in this range from 0 to L. So this is the core intuition here. Now we see 3, so 3, let's move now forward. 3 and 3 are the same, so let's move forward. 4 and 3 are not the same, so I'm going to move left to the next, and let's update the value at left with the value of right. Now let's move right to the next. Right is pointing out of bound. So we're done. We have sorted this array with distinct element at up to index 0 up until this point. Okay, so now what I have to do, we have to just return left plus 1. We have to find out the index, the length of this subarray. The length is we can say left minus the index of our first element 0 plus 1, or we can just here return L plus 1. This is the core intuition. This algorithm will take of n time complexity, where n is the length of the given array, and the space complexity is constant because we are solving this problem in place. We're not using any additional space to solve it. Hope you have understood how we should proceed here and how this algorithm works. If you guys have any question, ask the question in the reply chat. I'll be glad to answer them. Let me check if there is any questions in the chat forum. Actually, there is no question. So if you have any question, you can ask. If you have any issue understanding these algorithms, let me know. I will give you the explanations again. All right. Anyway, now let's start coding this algorithm. This problem exists on this site, LeetCode, right here. Now let's see the algorithms here. So the first thing we have to do, first we have to create a variable. All right, so first we have to create a variable left equals to 0, and we will have another variable right equals to 0. They points to the same element at the first time, and we will be running this loop, this while loop, while right is less than nums.length, or while right pointer is not out of bound. Now right inside here, what we're gonna do, we're gonna check first thing. Let's get our current element, so let's call it int current equals to we don't need this actually. Now here I'm gonna check if the value at left and value at right are not the same. So if nums at left is not equals to nums at right, if this condition is true, what we're gonna do, if this condition is true, what are we gonna do, we're going to just move left to the next, or we can add 1 to left, just move left to the next and just update the value at left with the value of right. So nums left equals to nums right. This is all about it. This is our algorithms, and at every stage we have to move right to the next. So right plus plus. And at the end, we have to return the length. So return left plus 1. This is so simple algorithms. Hope you've understood how to solve this problem efficiently. Now let's run this code. If anything goes wrong, we'll fix. All right, accepted. Let's submit it. It's accepted. We have solved this problem. This is how we can solve this problem pretty easily. I hope you've understood how to solve this problem. If you guys have any question, you can ask. I want to end this live right now. There is no question I saw. So anyway, I'm gonna just end this video right now, and I will see you next time. Till then, take care.